Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here today at Old Elementary School, home and nights, and today we're all here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
And in studio with us we have Karter. And Karter, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@current.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
A lot of sixes in there, huh?
Yeah.
Okay. While you're here, why don't you let everybody know where you go to school and what grade you're in?
So I go to Old River and I'm in 5th grade, and my teacher is Miss Hilliard there.
Oh, good. How's 5th grade going?
Good.
If you could change one thing about 5th grade, what would it be?
Not a lot of homework.
You mean you don't get a lot of homework?
Well, less homework.
You
for
want
the
more
kids.
homework?
Less homework for the people.
Oh.
I have a lot.
Okay, I see what's going on. All right, well, that's fine, because guess what's going to happen when you get into 7th grade?
A lot.
Oh, you're going to get a lot of homework. So if you don't have a lot right now, that's fine. If you do, you should ask for more. So you say, I want to get in training for when I get into higher grades, so I'm able to do all of that. Yeah, well, we'll see how that works out, huh? All right, you ready to do a little math?
Yep.
All right, over to the board, young man. So we're going to start off with a little discussion about exponents. So what I would like you to do is explain to Marylou anything that you know about exponents right now.
So exponents have a base and then an exponent. For example, 2. This question would be 4 to the power of 2. And how it looks like is 4 times 4.
Which would equal?
Would equal 16.
What do you think the biggest mistake that students make when they are dealing with exponents?
They would think it would be 4 times 2.
And why is that?
Because they think it would be 4 times 2.
Okay, and what's 4 times 2?
4 times 2 equals 8.
And a different product, right? Than what we really want. We want 16, we don't want 8. So what other information do you know about exponents?
If it is 5, if for example 5 to 0, it would not equal 0.
Why not?
Because 5 times 0, 5, like if 5 times 0, it would be 0, but you can never have a 0 in exponent, because 5 times 5 is 5, 2, 5, 1
Okay,
is.
let's look at it this way. Let's use 5, okay? So if I have 5 squared, okay, over 5 squared, okay, we know that this is really saying what? 5 times,
5,
right? And the bottom is,
5 times
okay,
5.
write that for me. So can I go 5 divided by 5?
Yes.
Okay.
And they would equal 1.
Right. But if we work this out, what's 5 times 5?
5 times 5 is 25.
25. Okay. And we know 5 times 5 is?
25.
Okay, put that on the bottom for me. So what is 25 divided by 25?
1.
1. So we can also look at this, and I can go 5 divided by 5, I know is 1, right?
Yep.
And 5 divided by 5 is?
1.
1. Do I really have any 5s left?
No.
I have 0.
0 5s, which would be the 5 and the 0.
Right. Which would be the 0, and that is why anything to the 0 power always equals
1.
1. Now what if I have 5 though to the first power?
It would be 5, just 5. Because the 1 would mean how many, like the number, exponent, would mean how many 5s are there.
Exactly, and we only have
1.
1 5, which is 5. Good job. Nice job. Anything else you would like us to do?
For right now, that would be perfect. So I'm glad that you went over the 5 to the 0 power. Anything to the 0 power is going to be 1, but a nice explanation as to why that happens right there. So nicely done. Hey, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, so today's Math in the News has to actually have something to do with what happened this past weekend. And you're fully aware of what happened this past weekend, right?
Yeah.
What was that?
Leap year.
Right, we had a leap year, right? Because we had a leap day, right?
Yep.
Which was,
The 29th, because every year, well, every 4 years, there's a 29th, not a 28th.
right, all right.
Well,
And
last day
we were having a
is
discussion about this earlier. If you were born on the 29th, right? And when would you say you would celebrate your birthday? It was based on something, right? Do you remember?
Yeah, it was either like if you were born in PM, well, like if you were born in noon, it would be like the time of the day. Like if it was 12, you would be on the first, and if you were on 11th, well, born on 11 a.m., you would be born on morning.
Oh,
Right.
I
So
did not
that's
know
when you would
that.
celebrate your birthday, right? So he was thinking, all right, if your birthday is on the 29th, you're born on a leap day.
Yes.
If you were born in the AM, you should celebrate your birthday on February 28th every year. If you were born in the PM, you should celebrate it on March 1st every year.
And we actually, I think, had 3 birthdays.
Yeah, I
And
remember
current
hearing about a
calendar.
couple of them. I wasn't sure how many we had. But here it is. Why do we have leap year? Even though the standard calendar is 365 days, Earth actually takes a little bit longer than that. This is called a solar year. In order to keep the calendar cycle synchronized with the seasons, 1 extra day is usually added every 4 years as February 29th. And you can see the graphic that we have right there. And the way this all came about is Julius Caesar. Are you familiar with Julius Caesar?
Yeah.
All right. Introduced the solar calendar to the Roman world, standardized the 365-day calendar, and in 1582, Pope Gregory XIII created a modified calendar, and it was called the Gregorian calendar. Now, why do you think it was called the Gregorian calendar?
Because it was named after the guy.
Right, after Pope Gregory, right? So he's like, well, you know, if I'm going to come up with a new calendar, we're going to call it
After
after me.
myself.
So the Gregorian calendar, all right? So he put it into place, and the rest of the world just kind of was like, okay, we'll go
follow it.
along with it, all right? Now, here's the reason I bring this up. A pair of Johns Hopkins professors believe it is time to get rid of the Gregorian calendar, all right? You will never have to buy a new calendar again, all right? The idea is simple, they say. Start every year on Monday, January 1st.
Okay.
Every other day would fall on the same day every year. Change would be no problem, just like when Canada went to the metric system, same thing. So the US would be setting precedent here, all right? Holidays, except for the 4th of July and Thanksgiving, would always be on a Monday. creating long weekends and never having midweek holidays like that, right? Where you disrupt it, it's like, all right, well, what days do we get off and how long are we going to have off?
Yes.
There would be no battles over the start of the school year, sports seasons. There would never be a Friday the 13th.
Yes.
You know about triskaidekaphobia? That's serious stuff, isn't it? All right. Do you have that? Fear of Friday the 13th? Neither do I. Yeah. All right. So anyway, they're saying, well, how would this happen? All right. An executive order by the United States president, the government, right? Yeah. If the government switched it, then other countries would just kind of fall in line, they say, and this would all be settled right there with that. So somebody else brought up another point. It's unclear what would happen to paper calendar and planner companies.
Oh,
okay?
Yes, that's right.
Because hundreds of millions of dollars are spent on paper calendars. Even though we live in a digital age right now, there's hundreds of millions of dollars in that every year. So that's just another point to bring up with these guys in their one calendar every year.
It would cause a shift somewhere else. Even though they're doing this, you have
one
some
thing
kind of
happens
shift.
someplace, something's going to happen someplace else. Anyway, that is today's Math in the News, a little bit about leap day and leap year. 636-4357 is that phone number. Phone tutors are available until 5:30. Right now we're going to head out and see how the nights are at Noble Elementary with Devin.
Hey, thanks a lot, Mike. We're here today at Noble Elementary School, home of the Mighty Knights. And we're with a great group of fifth graders here, about 11 in total. And we are going to attack the info gap. Now, info gap might be something you're familiar with, but it kind of takes what we think of as far as traditional math and problem solving and flips it along its side. So we're going to kind of change the game a little bit today as we explore the info gap. The first thing we're going to do is a little bit of a variation on the Guess My Number game. We have a wonderful space we're working with today. This space, while we look at it and see it as kind of a music space, there's a lot of instruments around, there's signs that help out with that. What we're going to be doing is actually using this space and everything that's in here, and we're going to make it a math space. So what I'm going to do with our first activity is I'm going to throw out there a number. Now, what your job in this room is to tell me what in that room that number is describing. Now, it could be anything. I cannot say. But instead of just kind of sitting and saying it and pointing it, I'm going to actually ask you to represent that by going to that spot. So, if everybody could stand up, please, at this time. Okay? What I'm going to do at this moment is I'm going to say a number. And what I'd like for you to do is to go to that part of the room where the thing that represents that number is located. Now, I have something specific in mind, but if you can explain what that number represents, who am I to say you're wrong? So there's going to be a lot of right answers that I'm not ready for. Are we ready?
Yes.
Our first number is 12. What could 12 represent? Go ahead and find your 12. Go! So there's a lot of different variety. There's not necessarily one thing in specific we're looking for. In fact, I'm getting ready to be surprised. Some 12s might be obvious, some not so much. Let's see what we found. Find your 12 in 3, 2, 1, and find your spot. Go. Now, this is really interesting. There's a lot of different spots. I'm going to jump over here with our group in this corner. I have 5 people that found the same 12. So tell me about the 12 that you found. What did you find?
Number 12 on the time.
Oh, so when we say 12, what you're identifying is what?
The time.
The time. So how would we say that time on this clock? So you've identified 12 o'clock as the 12 that I had in mind. Let's see some of the other 12s we may have found. I found a couple that went on over here. tell me about the 12 that you found.
The 12 on the calendar.
So you identified a 12 on the calendar here, okay? So the 12 you found, how would you what does that 12 represent?
The day.
So what day?
Wednesday.
So Wednesday, is there a certain month that falls in?
February.
So you've identified February 12th, a Wednesday, as your 12. I wasn't expecting that. Let's go ahead. I have 3 over here that have found a 12. Tell me a little bit about your 12.
The clock up there and like whatever.
So you found a different 12 on a different clock. So what could that 12 represent on that clock that might be different than what the 12 represents over there?
The time of the day.
Okay, so you're looking at a very similar 12 o'clock represented by the 12 on that clock. I had a friend over here standing on her lonesome. Not that that's a bad thing. Sometimes we all got to be alone. We need our moments to ourselves. And sometimes we got to shine on our own. So I want you to shine for me. Tell me a little bit about the 12 that you found.
12 is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12.
You identified 12 music stands on this carrier. So you were able to really like find that 12 and organize that quickly. You didn't necessarily count by ones. Was there a way that you saw 12 as far as bunches or groups that helped you count that 12 quickly? Like for me, I noticed that there are 6 over here.
Yeah, 6 and 6.
So you have 6 in that group and 6 over here. So we have 6 2 times, or 2 groups of 6. That's really interesting. Now, when we come back, we're going to do another Guess My Number round, but maybe not necessarily with a number. We'll come back to you from Noble in just a moment, but until then, Mike, take it away.
All right, thanks for that, Devin. We'll check in with the Noble Knights in just a little bit. In studio, we have 5th grade student Karter from Old River Elementary, and he would modify homework a little bit in 5th grade. So, what is something you're looking, because you're more than halfway through the school year, is there anything you're looking forward to in 6th grade?
It has to be like the Egyptian plate.
Oh, ancient civilizations? Yeah. All right, so you like the Egyptians and things like that? Well, good. Well, it'll be a lot of fun because you'll study a lot of those civilizations next year. But guess what? You have math to do right now. You ready? Yep. All right, back to the board, young man. So we know that you knew a little bit about the exponents, and anything to the 0 power is 1, and to the 1 is just the base itself. So let's talk a little bit about multiplying and dividing with exponents.
Okay.
All right? So Marylou is right there because I know you haven't done a lot of this, and we only touched on it a little bit. So
Now, I just kind of touched on dividing, didn't I?
Yeah.
Okay. Do you know anything about multiplying exponents?
So if you multiply for like 5 thirds, it would be 5, 5, 5.
Okay.
Multiplying a fraction, well, one of those, and another thing, you'd have to add those 2 together.
How do you get that?
5.
I agree with you, but why?
Cause like don't want to like write another 1 like that, and then like have it totally spaced out. And like, why would you have it spaced out when you could have just added it like that?
Yeah, and if I love the way you wrote it out, right? Here is 5 to the 3rd, and here is 5 squared, right? And if you count up the 5s,
You would get 5 5s.
right, we then have 5 to the
5.
5th power, right? Now, so let me ask you, does it work if I did something like this? Can I still just add?
No, because it would have to be the same.
Same what?
It would have to be the same base,
Oh.
not the same. Well, it wouldn't have to be like 4 plus 5 is 9. But it would have to be the same, because then it would be like the same thing.
So it does not work if I don't have the same base, right?
No.
I would have to completely solve both of these and multiply, right?
Yeah.
But when we have the same base, then
You could just add them.
we can just add them because it's really saying 5 to the 5th. Okay, so let's go to, I'm going to do another page here. Let's go to dividing, okay? So what's the difference with dividing from multiplying exponents?
So for another thing, like 10 and 10, like 10 to 8, 10 to the power of 8.
Okay, I'm going
And
to put a
then
fraction
10
bar.
to the power of 3, 8. And like, you could write it out, 10 tens is,
Okay, let's write this out. There's 1, 2, 3, 4, 5, 6, 7, 8.
Too bad he didn't put 10 to the 19th or something.
I
for you
know.
instead.
And then we have, do the 10 to the 3 on the bottom for me. So this is what it's really saying, right? So,
if you subtract those, it would be 8 take away 3,
okay, which
which
is,
was 5.
okay, write the answer for me. Well, we need the base, right?
Yeah. And
So
then
it's 10 to the 5th. Well, let's prove it here. What we're really doing is we're really dividing
those two.
those two. 10 divided by 10 is,
1, 1, and 1.
so what are we left with?
5 tenths, which would be, so it would be 10, 100,
Oh, he's evaluating
Ooh.
it.
Yeah.
1,000, 10,000, 100,000.
Okay, so what is 10 to the 5th then?
It would be 10, 100.
Or 100,000. Very good. So if we're multiplying, let's recap real quick. If we're multiplying
We're adding,
and if we're dividing exponents,
we're subtracting.
there you go.
Okay, so next thing I'd like you to do, clear that board.
Okay.
So you add 10 to the 8th over 10 to the 3rd. Now what
Okay.
I would like you to do is take 10 to the 6th
Go ahead.
over 10 to the 9th.
This is a little different.
Yeah.
What are you
It-
thinking here? We can't
it
say
would-
6 minus 9, can we?
It would have to become negative, which it is because it's 10 to the power of negative 3,
Okay.
which is a decimal.
You are correct, but this is exponent form, right?
Yeah, so-
So how can you write it in standard form?
It would, so there's an imaginary decimal right there.
Okay.
So 10, and then if you moved it 3 times, it would be,
What is that?
it's
You take
it's 100, no,
Yeah, you have
100
it.
tenths.
100ths, right? Because this is tenths, this is
100.
hundredths. So it's just simply 100ths. How do you write that as a fraction, though? Wait a minute.
It would be,
Let's,
Right, I
Let's
want you to
double
turn
check
it into a
this.
fraction.
yeah. How do you write this as a fraction?
fraction, it would be 100. It would be 10 to the power of 100.
Okay, well, wait. Is this 10 hundredths or is this 100th?
100. So it would be 100th.
100ths. Very good. And again, if we were to look at this, we would be crossing out 6 here, right? I take away 6 from here, and
Yeah.
I'm left with,
10. Well,
and then what goes up top? A 1.
Because
So instead of 1 over
So,
100, it should be,
It should be, let's look, yeah. Do I have just 2 here? You only have
No.
2. No.
it would be
So what are we missing?
another 10.
We need another 10, so we need another 0. So it's not 1 to the 100th, it's 1 to the
1,000.
And I want to talk about your strategy here, okay? Because you were saying that moving the decimal point over, and that strategy doesn't always quite work, okay? That's why we need to look at it this way, all right? Kind of bring it out, because that doesn't always work. And I'm going to kind of do a thing through that, okay? All right, there you go. Again, always double check your work with that.
so what you
okay?
can do is just take 10 to the negative 3 and make it 10 to the 3rd. But now that you make the exponent positive, it has to go under 1.
Wonderful.
So it's 1 over 10 to the 3rd.
So this is what you're really saying, right?
Yeah.
So we want to change that negative
To a positive.
to a positive, and by doing that, we're actually doing like the reciprocal of it, okay? We're flipping it, and you're right, it's going to be less than 1, so we're going to switch it to 10 to the third. And you notice the negative went away, giving us our 1/1000ths. Okay?
Nicely done.
you
Learning a
go.
little bit more about
Great
exponents
job.
and multiplying and dividing with those bases and exponents. Some great work right there. And for that great work, you've got yourself a meal courtesy of our friends at Grill & Burger. So congratulations on that. Hey, we do have phone tutors available until 5:30. We'll check in with Devin and we'll do some more math with Karter. All of it right after this. Today we're at Mojave Elementary, home of the Colts, and we're here to Today we're at Mojave Elementary, and we've got some 5th and 6th grade, well, 4th and 5th grade students today, right? All right, you guys ready to do a little math?
Yeah.
All right, so integers. Do you guys know what integers are? Like, how would you describe them, or what are they? Or have you ever seen them, or have ever heard of them? Never heard of them? You guys are in 4th and 5th grade. I'm sure you've heard of integers, you may just not realize it. All right, so let's take a look at, what do you think it is?
Isn't it just like number lines?
They're just numbers, right? But instead of just, because we all know 1, 2, 3, 4, 5, right?
Yeah.
They're just regular positive numbers, all right? If we have -1, -2, -3, -4, those are negative numbers. But all of those numbers together, just positive numbers and negative numbers, are all integers, all right? So take a look at the number line that you guys have the first, right? So it says integer number lines. So where does the number line start?
It starts at -15.
-15, and how high does it go up to?
+15.
+15, all right? So what's right in the middle?
The zero.
The 0, okay? So if you take a look at the 0 and you move to the right, are those positive or negative numbers?
Positive.
Positive numbers. You're positive about that?
Yeah.
All right, you got it, okay. So you're positive that those are positive. If you move to the left, those are what?
Negative.
Negative numbers, right? So as we said earlier, all negative and positive numbers, whole numbers like that, these are going to be integers, all right? So on your paper, what I'd like you to do is I'd like you to find 4 and put a circle around where you think the number 4 would be. No, you've got it, right? Everybody's got, it's 1 away from number 5, right?
Yeah.
Pretty easy, okay? Now find -7. So -7. All right, so we've got a couple of different marks, all right? So let's take a look. We know that here we've got 0, right? And if we go back to here, that's -5. So the one after that is going to be -6 and then -7. All right, so do you guys see where you're at? Okay. How many numbers are on this number line altogether? Say it if you know it. How many numbers are on that number line?
7? Oh, do we have to like add it or?
Well, look, if we start here, right, -15, there's 1, 2, 3, 4, right?
32.
30, right? The actual dots, right, if you count those at the end, right, you're going to have 32 of them, right? Okay. If you're at 0 and you go -15 and +15, now remember, 0 is also going to count, right? So a lot of people forget that that actually counts as a number, okay? So now what we're going to do is we're going to order them. You guys know what greater than, less than, and equal is? Right? So you guys know the symbols that are used for those? Okay. So let's take a look at the first one. We have 2 and 2. Now is 2 greater than, less than, or equal to 2?
Equal.
It's equal, right? So what symbol do you put in there? An equal sign, right? So up at the top, you have the 3 symbols, okay? What's that first symbol for?
Greater than?
Okay, so take a look at it. We would say that 2 is less than something. Okay, and then the other one is greater than. All right, so let's go to the very next one. -8. Is -8 equal to 8? No, it's not equal to 8, is it? Right? One's on the negative side and one's on the positive side. So which is larger, 8 or -8? 8, right? So we need to put the symbol so that it says that 8 is larger than -8. So do you guys know which one that is? Right? So the way you would read it is you would say -8 is less than 8. All right? So we'll do a few more of these, doing some integers, negative and positive numbers with the 4th and 5th grade students at Mojave Elementary. And once again, a big thanks to the staff and students. I had a great time at Mojave Elementary School right there. We do have Karter in studio with us, a 5th grade student from Old River, and we're going to get him working on some more exponents in a minute. But right now, we have another opportunity to head out to Noble Elementary and visit with Devin.
Hey, thanks a lot, Mike. Back here at Noble Elementary School, playing a little bit of guess, not so much my number, but find my number. We started off with 12. I would throw 11 because we got our Noble 11 proud and strong here, very observant. We're going to change the script a little bit. For this round, we're not necessarily going to find a number. We're going to find an expression. So I'm not going to simply give you a number, but I'm going to give you an expression that is represented, that I see laid out somewhere, somehow in this room. Now, it could be very tempting and very easy to just put these numbers together and find out a solution and just find that solution represented somewhere, but I don't want to do that. I want to see if we can find how this expression could be represented by something in this room. So, here's what I want to see if we can find. Are you ready? Yeah. Find my expression. 1 plus 3 plus 3. 1 plus 3 plus 3. Give yourself a chance to look around where you are. Now, you don't have to worry about finding what 1 plus 3 plus 3 is. That's 7. I'm not looking for 7 specifically. I'm looking for a representation of how we could see 1 plus 3 plus 3 somewhere in this room. Are we ready? Yes. 3, 2, 1. Go ahead and find 1 plus 3 plus 3. Again, the beauty of this activity is that everybody might find their own thing, but when they get there, they might be starting to talk a little bit about how they identify things or what they might be finding. And the conversation is leading a lot of people to the same spot. But some people in that first spot might be venturing elsewhere to see if they can find a different representation. So it's really interesting to see this develop. We're going to give everybody another few moments or so to explore where they might find this, because they're really utilizing all the space. I love the kind of math where people just get around and they move, because there's a lot of brain research that shows that when we're upright, when we're moving, we think more critically and more crucially. Okay, ladies and gentlemen, find your spot in 3, 2, 1. And would you look at this? I think everybody just kind of gravitated towards this area here. So could you show me somewhere where 1 plus 3 plus 3 is represented?
1 plus 3 plus 3.
So, okay, what are we looking at? What are we representing? So what are these, by the way?
Books.
Boxes of books? Okay. These are kind of science books. So you see 1 plus 3 plus 3 represented as 1 bucket on top plus a row of 3 plus a row of 3. That's really interesting. Okay. I'm going to go ahead and throw out another expression. This one is going to be a bit more complex. It's going to involve more than one operation this time, okay? So here's what I'm looking for. I'm looking for 3 times 4 plus 2. 3 times 4 plus 2. Take a moment, look around the room, and see if you can find a representation of 3 times 4 plus 2, somewhere in this space. So starting in 5th grade, students start to examine concepts of order of operations as far as how to represent different groupings and what that might look like. So with an expression like this, and especially expressions that have two operations that complement each other, such as addition and multiplication, it's interesting to see how students might recognize those. And we have some different setups here as people kind of look around the room. I'm going to ask you to find your place in 3, 2, 1, and go. We have a couple of different groups over here. One, which I did kind of have in mind. Another one that I really want to ask about. So let's jump on over here. Tell me a little bit about 3 times 4 plus 2.
So,
okay, 3 times 4 equals 12, plus 2 equals 14. And right here, you can see that right here is 14.
Now, and what's interesting too, tell me where we see the 3 times 4 part first.
Okay, sure. Right here, 3 right here, and 4 right there.
So we see 3 rows and 4 in each row. Where's the plus 2 then? Down here. So this is a separate group of 2. 3 times 4 plus 2. There's another group back over here I want to check. Oh, hi. They were still talking and they got caught again. But you didn't get caught. You got found. And I want to see where you saw 3 times 4 plus 2.
okay. 3 times 4 plus 2.
So what are the 3 times 4 that you've identified?
3 violins, the other 4 violins, and then the 2 instruments.
Let me do this, if it's okay. Because I think we have a group of 3 and a group of 4. Is that 3 times 4? Or is that something different?
What's your question?
So I'm looking for 3 times 4 plus 2.
Yeah, 3 times 4 plus 2.
So we have 3 violins, but where's the 4? Because I might recommend something. I hope there's something in here, actually, because that would be awful if it wasn't. There is nothing.
There's probably some in the middle.
Okay, let's try this one. These all feel very empty. Let me ask you a question, musically inclined. If there was a violin in there, how many strings would be on that violin?
4.
So, the 3 times 4 could represent the number of strings on 3 violins. And then, how many bows did we have?
3. Oh, 2.
So, we can say, if we consider each of these bows as 1 string, we could say that 3 times 4 plus 2 represents the number of strings on these objects here. I was not expecting to look at those violins, but that connection is there. We're going to send it back to the studio for one more info game when we come back. Until then, Mike, take it away.
All right, we'll check with you guys later on in studio. We do have Karter, and Karter's, you've been relaxing the last couple of minutes, huh?
Yep.
All right, get back to work then.
Let's go.
All right, so we know we've expanded your knowledge a little bit about exponents. So now let's apply that knowledge.
Yes.
All right, here we go. 6y squared
Square.
f to the 6th over, so put your bar,
Oh,
the whole thing, yeah.
There you
Now
go.
make sure you know that 6 is an exponent.
Yeah.
There you go.
Yeah.
Oh yeah, you've got your hand on the board. That's what happened there. To the 6th. Over 4 y to the 3rd f to the 5th.
all right, Carter.
All right.
What are you thinking?
So if the 6y,
That's
6,
2y
yeah,
squared.
6y squared, and f6, we could, like, f6, we wouldn't know, so
Well, let's look what's the denominator.
the
What
denominator.
comparisons can we make using your prior knowledge of adding and subtracting exponents?
It would be f1,
Where?
Right.
F1 in the bottom or F1 in the numerator?
well, 6 take away 5 is 1.
Okay. So where am I talking? Numerator, denominator? Which has more, numerator or denominator?
Numerator.
So we want f to the 1. Okay,
As a denominator. As a numerator.
that's the numerator. So what else can you?
6y take away 4y would equal.
Can we really though? Can we? Oop. Go ahead. Thank you. Let's look at this. I'm going to put a multiplication in between these. Okay. Right? We're multiplying all these. Yes.
Yep.
So let's separate the 6 from the y squared. Okay. And let's separate the 4 from the y cubed. So let's focus first on your y's.
So y2 will be, well, y2 take away y3 would equal -1. Well, y -1.
Okay, now let's think back. How do we write that as a positive fraction?
It would, so as a fraction, it would be y -1, and then you would have to take the reciprocal and change it.
Okay, which would be?
y1 over 1.
Okay, so I'm going to put our answer, oh, that's probably too high up there, sorry. Let's put it over here. Okay, first you have f to the first, right? So where is this y1 going to go on our answer? Is it going to go numerator or denominator?
Denominator.
Very good, let's put that there. Okay, y to the first, right? So now we're left with,
Now, before you continue, do you even need those exponents of
Yeah.
1?
The exponents, we don't need them because f1 would just equal f.
okay.
And y1 would be y.
Okay, so let's go ahead and take those off. So now we're left with 6 over 4.
It would be 6. 6 over 4 would be 1 and 1/2.
Okay, but I need it as a, you could do 1 and 1/2, but we need to leave it as a improper fraction. So what would it look like as an improper fraction?
6/4.
Okay, can you simplify that though?
Yes, to 1 and 2/4.
Oh, but I want it as numbers. What can, I want it as an
He's
improper
simplifying
fraction.
farther than you want him to.
Yeah, give me an improper fraction. An improper fraction is, what number can I divide both of these by, first of all?
2.
Okay, so what's 6 divided by 2?
3,
And what's 4 divided by 2?
2.
So 3 over
2.
2. So let's take this knowledge of 3 over 2. Where is that going to go in our answer?
3 would go up over here, and then 2 would go under here.
Okay. So because mathematicians, we have an order of things, we like to have these numbers in the front. So let's rewrite this as 3f over,
2y.
very good. And we have simplified everything down is what you've done. Okay, so overall, our 6y squared f6 over 4y cubed f to the 5th, we're simplifying it down to 3f over 2y. There you go.
Nicely done. You like that, Karter?
Yep.
That's pretty fun, huh?
Yep.
All right, erase the board. I got another one for you.
Okay, here we go.
9y squared over 7y cubed r to the 5th.
Okay, so Karter, where do you want to start? Anywhere. Where do you want to start?
So y2 take away y3 is again a negative number.
So
would be-
where do we want to put it in our answer?
It would have to turn to y1
Okay,
or
numerator, denominator.
denominator.
Okay, put it there.
Wait, 7. y1.
And do we need again that 1?
No.
Okay,
'cause y1 would be y.
Okay, let's get rid of the 1. So now where else do you want to go with this? We
Okay.
took care of our y's, right? I'm going to
Our-
cross that out.
5 we have the R5, which we do not know, so what would it be?
Well, let's see. Is there anything in the numerator to compare it to?
9. But that's
But what's your base?
R.
So we have to have the same base. Remember we talked about that earlier?
Yep.
We have to have the same base. But are there any R's in the numerator?
No.
So what do we do?
We just
Do we have
leave it.
we what?
We just leave it.
Exactly. There's nothing to compare it to, is there?
So we just move it along
Okay. I like the way you said that. Move it along.
to YR5.
Okay. Now what are we left with?
9 and 7.
Can that be simplified?
Yes, to 9 over 7, which nothing can go in the 7 and in the 9.
Very good. So where does it go in our final answer? What do you think? Where do you think this 9's going to go in our final answer here?
It would go, well, the 7 would go right here.
Okay, put that there.
And then that means the 9 would go right here.
He's got it. I think you have it down. Whoops. There you go.
2 for 2 right there. All right, here we
Nicely
go. We're going
done.
to go for the trifecta. A beautiful problem I've got for you right now.
Okay.
KC over 5,
What, over? A down?
5, K to the negative 6th, C to the negative 5th. All right.
Okay, so on this one, I want you to use your knowledge first off. Let's deal with the easiest thing, the 5.
Which would be left alone because there's nothing on the denominator.
Perfect.
New.
Okay, let's leave that alone. So now we have our K and our C, and what's our ghost of an exponent?
1.
Thank you. So I want you to think about this though, okay? We have 2 negatives. What was the little thing that we talked about with negatives?
We could switch them to
Okay.
a positive.
But if we're going to switch them to a positive, what do we have to do to them first?
Switch them up here.
Okay, so let me show you a thing first of all. Let's leave these negatives, okay? We know that when we're subtracting, okay, a little bit of rules about negatives. If I am saying 3 minus 5, right? We know that that answer is going to be negative 2, right?
Yep.
But what if I'm saying 3 subtract negative 5?
It would,
So what do you think the answer is going to be here?
it would have to be, you would have to change it because in subtraction with that, you can't have
Right.
subtraction.
So what am I really doing? Am I subtracting?
You're going to have to change the 5 to a negative
Okay.
5 to a positive 5.
Okay, so what's my answer then?
It would equal 8.
Okay, let's take that same thinking here. We know that we're supposed to be subtracting these, right? But what we're really saying is 1,
Take away 6.
what kind of
negative
6? Negative 6.
We
So what is
can't.
that?
We change it to a positive and get that. We make
Okay,
it that.
so what's my answer?
7.
Okay, so is that a positive 7?
Yeah.
So do you think that we are going to be putting that positive up top or below?
Up top.
Okay, so it's going to be K to the what?
K to the 7.
Okay, now you go ahead and do the C. for us.
C, negative C with negative 5 plus,
Oh, we say negative 5 plus? What's our numerator first?
it would be
Always go numerator first,
C plus 1. I mean,
right?
take away 1.
Take away.
Well, take away C negative 5, and you would have to change the subtraction,
2A.
addition problem, and then you would have to make this positive.
So it's going to be C to the,
Positive 5th, or
what are we adding? What 2 numbers are we adding?
we're adding 1 and 5, which would equal C6
And where is that going to go in our answer?
right here.
There we go. Ask Mr. Cushon if we got it.
Is it true?
True. All right. I've got one more for you. And this one, Marylou is not going to speak.
You can
Are
do
you
it.
ready?
Yeah.
7 to the 5th power over 7 to the 2nd power.
So you would have to take away 5 and 5. 5 take away 2 is 3. 7 thirds. And then 7 times 7 is 49. 49 times 7 is 63. 63. Then 4 times 7 is 28. 28 plus 6, that would be 34. So it would be 34. It would be 343.
There you go, nicely done. You actually only needed to leave it as 7 cubed, and that would have been it with me.
Nicely done,
But
kiddo.
when you can evaluate it, even better right there. Nicely done, young man. Come on over here. Do you have any idea what you'll be receiving for that hard work on those exponents?
Probably a gift certificate to place.
Yeah, someplace, right? Have you ever seen the Bakersfield Condors hockey?
Yes.
You have. Well, guess what? You're going to go again because we've got a couple of tickets for you to bring a guest along, and you can go see a game with the Bakersfield Condors for that great work right there. We do have phone tutors available until 5:30 this afternoon. We do have one more opportunity to head on out to Noble Elementary and visit with Devin.
Hey, thanks a lot, Mike. Back here at Noble Elementary School, back with our Noble, and we still have 11. Did anybody leave? No. Noble 11, everybody. And we have been diving into the info gap game of Find My. It's a very easy game, and you can use whatever space you're in, especially ones, you know, I mean, how many classrooms have we been in where there have just been stacks of stuff lying around? And instead of just letting it collect us, let's actually utilize it. We see math everywhere around us, so let's put it into place. So, a big part of 5th grade math that unfortunately I don't think we really get to see until later on in the year, but it, to me, is my favorite part of math, geometry. I love the idea of shapes and figures and making sense of them. And, you know, when you're in kindergarten, it's the best part of the year is playing around with triangles and rectangles. A big part of 5th grade math is 3-dimensional shapes. So, what we are going to do is do an info gap game, not necessarily about find my number, not necessarily about find my expression, but find my figure. So I'm going to describe a 3-dimensional shape. And I would like for you to be able to identify that, if you can. Okay? So we're not doing flat shapes, we're not doing 2-dimensional, we're not just doing triangles or rectangles. We're doing 3-dimensional objects, okay? So, if we could, let's begin. Find my, let's start off real straightforward. Find my sphere. Find my sphere. Okay? Find my sphere. All right. Find my sphere. Could be anywhere. There may be more than one. Okay. All right. There's a lot of different spheres that people have found here. Very interesting. Okay. This may be the most scattered we've seen a group in this room. Okay. 3, 2, 1. I'm going to work counterclockwise and see. Actually, let me work clockwise here. So let's start off over here. Okay, go ahead and show me where you see a sphere.
We found a clock.
A clock.
That
Now,
shows time and day.
yes, I would agree that a clock does show time and day. Tell me how this is a sphere.
Because it looks like one and it's a circle. Like one.
Now, circles do have a relationship with spheres. A sphere is essentially a point in space where if you start at a center, every point around the sphere is the same distance from the center. Now, is that necessarily the case with the clock? Like if I take a point from the back of the clock, is that just as far away as a point to the bottom of the clock from the center? Probably not. However, you saw an object, you were looking up around this area and saw something that was very close. What did you see as kind of a sphere?
I saw that.
Now that's interesting, okay?
Yes.
Why do you see that? You see what we're talking about? We're talking about the handle at the end of the string for this pull-down projector. So tell me how you identify that as a sphere.
Because what I thought of a sphere because it kind of almost looks like one, but the bottom is missing though.
So if we have the bottom back on top of that, you think that would identify as a sphere?
Yes.
That's a really interesting observation. I want to thank you for sharing that. That was really interesting. I did not look at that thing and think sphere, but he's thinking of the complete picture. Let's go over here and see if we can identify a sphere over here. Where did you see a sphere?
We found 3 stuff.
You found 3 spheres just right over here. Go ahead.
The first one that I found was the fire ginger.
Okay. And where did you find yours?
I found the doorknob.
Okay.
This.
So how do you identify these as spheres?
Because spheres usually, they're not just a circle. They usually go back more.
So I think there's a point of clarification that is really important here. If we think of a sphere as kind of like a roundish object, these are a little different because, like, if you were to take cross sections of each of these figures, you would end up with a bunch of the same types of circles, right? So that's a really different type of shape. That's actually called a cylinder. So we think of like a can, for example. It has the same circle on the top and bottom, or the sides, and then it's kind of like a rectangle or a series of those same circles stacked around each other. So I would agree that most of these are generally cylinders. As far as spheres, though, if we think of a point and everything around it being the same distance from the center of that point, do these qualify?
We also found that.
Well, that's again would be a longer cylinder because this eye hole here goes all the way through the door. So we found a lot of cylinders, but we see a lot of spheres over here. I see like a bunch of people in the same area, but looking at different things. So I want to look at our friends over here. She's juggling. Whoa, that's 2-handle juggle. So we have 3 spheres being held over here. Tell us a little bit about these spheres.
They're yarn balls.
Okay, so how do you recognize these as spheres?
They're round and they're like a circle, but they're not solid.
So they're not necessarily solid, okay? And now over here you found, well, they are solid, but they're circular all the way around. Let's talk about the sphere that you found over here. The Earth. Now, that's a great example of a sphere abstractly. Did you know that the actual Earth is a little bit flatter at the top than it is on the sides? Not by much, like 23 miles. So technically it's an oblong spheroid, but as far as a sphere that you've identified and recognized, I mean, that's a very visible example. We see math everywhere. And just because one group sees the same thing differently, everybody's validated. Hey, thanks to everybody here at Noble Elementary for helping us clear the info gap. We're going to send it right back to the studio for the last time today. Mike, take it away.
All right, thanks for that, Devin, and thank you to the students over at Noble Elementary. We do have phone tutors available until 5:30 this afternoon. We want to say thank you to Karter for coming in this afternoon and spending a little time with us. You know that you are now an ambassador for Do the Math, correct?
Yep.
You know what that means?
For being here again.
Well, that's good, but that means you have to tell other kids about Do the Math. Can you do that?
Yep.
All right. Did you learn a little bit today?
Yep.
A lot about exponents and stuff right there, huh? Did you have fun?
Yep.
Good. Well, that's what we want. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.